This is Mr. Simmons for section 8.4, multiple representations of functions. Represent functions using words and equations. Here's a statement. A runner's distance in a marathon is equal to 8 miles per hour times the number of hours. The equation that we have there is the distance d is equal to 8, which is our miles per hour, times our time. Words and equations can be used to describe functions. For example, when a rate is expressed in words, it can be written as an equation with variables. When you write an equation, determine what variables to use to represent different quantities. Example A. A mouse can travel 8 miles per hour. Write an equation to find the total distance d a mouse can travel in h hours. So from before, we have distance equals rate times our time. So now they give us a distance, or we're actually trying to find the distance, so d equals, and we know that the rate that the mouse is traveling is 8 miles per hour, and so that would be our equation. Example B. Samantha can make 36 cookies each hour. Write an equation to find the total number of cookies C that she could make in h hours. So we have 36 cookies per hour, which we can find out how much she can make as a grand total amount of cookies. So simply put, if she worked 0 hours, she would be making 0 cookies. If she worked 1 hour, 1 times our 36 says that she would make 36 cookies. If she worked for 2 hours, 2 times our 36 would give us 72 cookies. This next page, tables and graphs can also be used to represent functions. The table on the left, where it compares our time to our distance, our 0, 0 is at our origin. Our 1, 8 says we go across 1 and we're going to go up 8. The time for 2 is equal to the distance of 16. So one thing to notice too is that the intervals are not equal on each axis. The x goes up by 1/2 hours at a time, and each interval on the y-axis for our distance will go up by 4 miles at a time. Our final examples. While in normal flight, a bald eagle flies at an average speed of 30 miles per hour. Write an equation to make a function table to show the relationship between the total distance d that a bald eagle can travel in h hours. So from before, and as we've been using so far, the distance is equal to our rate multiplied by our time. So again, we'll start with 0, 1, and 2. And if we substitute the values in, 30 times our 0 will give us 0. 30 times our 1 will give us 30. And then 30 times 2 would give us a distance of 60. The final part of this, it says to graph the ordered pairs of the function, and then we want to analyze our data. So if we look over here, 0, 0, says that if no time went by, the eagle didn't fly any distance. After 1 hour, it says that the eagle flew 30 miles. And after 2 hours, the eagle flew 60 miles. If this is a true function, we will have a straight line for our graph, and we do. Please complete the problems from page 606 in your book for tomorrow. This is what they look like. Please make sure that you have your book, and also make sure that you guys are writing neatly in your book.